Hi friends, welcome to KPB Coding Hub. In this video, we are going to discuss about bitwise operator in C language. This bitwise operator is used to perform operations on binary values. So that is zeros and ones. So if you want to perform operations on zeros and ones, then we are going to use this bitwise operator. This bitwise operator is mainly used for numerical computation. The following are the bitwise operators supported in C language. So this is bitwise AND, bitwise OR, bitwise XOR, bitwise left shift, bitwise right shift, and this is complement. I think we have discussed already about this AND OR in logical operators. Let me explain again. AND. It is going to return 1 if both the bits are 1. Else it is going to return 0. And bitwise OR. It is going to return 1 if any one bit is 1. Else it is going to return 0. And cap. This is also called as exclusive OR. It returns 1 if both the bits are in opposite direction. So let me explain this by taking an example. Consider there are two values like V1, V2. Let me take V1 bitwise and V2, V1 or V2. V1 cap V2. So I'm taking the values like 0 and 0, 0, 1, 1, 0, 1 and 1. So V1 and V2. It is going to return if both the operands are 2. In other cases, it is going to return 0. V1 or V2. It is going to return 1 if at least one operand is 1. So in the first case, it is 0, 1, 1. So V1 cap V2. This is opposite. If both the operands are same, it is going to return 0. If it is opposite, then it is going to return 1. So 0, 1, 1. And in the last case, it is going to return 0. The operations on bitwise operator can be performed in two methods. One is LCM method, and the second method is by using 84214. Let me explain by taking LCM method first. Suppose if we want to find the binary value for 8, one method we can do is by taking this. If I want to perform by using LCM method, consider the value is 8. We are going to divide this with 2. 2 4s 8 and the remainder is 0. 2 2s are 4, remainder is 0. 2 1 is 2 and the remainder is 0. So we have to write like this. The binary value for 8 is 1 0 0 0. This is the first method. So the value of 8 is 1 0 0 0. And the second method you can do is 8 4 2 1. By using this method also we can go. Consider if you want to find the binary value for 1. 1 is present in this way. 2 power 0, 2 power 1, 2 square and 2 cube. So in the remaining places you have to replace it with zeros. Wherever the value is present, you have to place 1 there. Binary value for 2. So 0, 0, 1, 0. 3. The binary value for 3 is not present directly. So we have to add this 2 plus 1. So in the first case it's 0, 0, 1, 1. 4. 0, 1, 0, 0. Binary value for 5. So 0, 1, 0, 1. 6. 0, 1, 1, 0. 7. 0, 1, 1, 1. 4 plus 2 plus 1 is 7. So we have to add this. In those places we have to place 1s. I'm going to take the values like a equal to 5 and b equal to 7. So first operation is a and b. So the binary value for 5 is 0, 1, 0, 1. And the binary value for 7 is 0, 1, 1, 1. And operation. And if both the operands are true, then it is going to return 1. So this is 0, 1, 0, 1. And its value is 5. The next one is A or B. A value is 50101 and B value is 70111. Or means if at least one operand is true, it is going to return true. So 0111 and its value is 7. The next one is A cap B. The value of A is 5. So 0101 is a binary value and 70111. Cap means if both the operands are 0, it is going to return 0. If the operands are opposite, it is going to return 1. So 0, 0, 1, 0. Its value is 2. Next. A left shift of 1. So we are going to shift the value of A to left side. So that is the value of A is 5. We are going to perform 5 left shift of 1. For shifting purpose, definitely we are going to use 8 bits representation. For this also we can use, but remaining will be zeros. So first 4 bits are zeros. Next 4 bits are 0, 1, 0, 1. Left shift. How we can do this is, let me explain you. So 5 left shift of 1. What is the binary value for 5? It's 0, 1 and 0, 1. So we have to use 8 bits representation. So 0, 0. First 4 bits will be 0. Next 0, 1, 0, 1. We are going to shift this bit to left side so it gets eliminated. And this will be shifted here like 0, 0, 0, 0. This one is going to shift here 0, 1. At last, we are going to replace it with 0. Now we have to find 8, 4, 2, 1 for this. So 8, 4, 2, 1. Wherever 1 is present, we have to add those. 8 plus 2 equal to 10. So the value of left shift, 5 left shift of 1 is 10. So its value is 10. There is a trick for this. If you want to perform left shift, then you have to perform the operation like you have to multiply with 2. So the given value is 5. 5 left shift of 1. So you have to multiply 5 with 2. 5 into 2 is 10. So the output is 10 here. If you want to perform 2 shifts, then 5 into 2 into 2. This is the procedure. Similarly, we are going to perform right shift for B. B right shift of 1. What is the value of B? 7. 7 right shift of 1. So the binary value of 7 is 0, 1, 1, 1. And remaining places it is zeros. B right shift of 1. B value is 7. So 7 right shift of 1. We are going to shift the value of 7 to right side. So this gets eliminated. This one is shifted here. 1. And remaining places are filled with zeros. Let us find 8, 4, 2, 1 for this. 8, 4, 2, 1. 2 plus 1 is 3. Hope it is clear for you. So its value is, if we want to perform right shift, then you have to divide by 2. This is the trick which we have. The last one is complement. For this, we have a big procedure, but I'm going to explain it very simple for you. Suppose if you want to find complement of n, then the formula is minus of n plus. If you want to find complement of 5, then we have to use minus of 5 plus 1 minus 6. Now let us run this in online compiler. I'm going to declare the variables like a equal to 5 and b equal to 7. We are going to perform all the operations. A and B. The next one is A or B. A cap B. A left shift of 1. A right shift of 1, or you can do right shift for 3 also. Let me take B right shift of 1. The last one is complement. Let me execute this. So A and B is 5, A or B is 7, A cap B is 2, A left shift of 1 is 10, B right shift of 1 is 3, and the complement of A is minus. This is about bitwise operators. Thank you, friends.